Assalamualaikum and hello everyone. Welcome to the video for 5.2 Alkene. This video we will learn to illustrate the mechanism of electrophilic addition of acidified water. In 5.2, overall we will see three mechanisms. The first mechanism that we have seen is actually the first one is dehydration of alcohol. This video we're going to look for the reaction of electrophilic addition of acidified water, which is on your notes. It will be on page 21. Okay, so for the electrophilic addition of acidified water, it will convert our alkene to our alcohol. So it means that on our alkene itself, we're going to add H2O to form our alcohol. So that's why the name of the reaction is hydration of alkene. But the type of reaction is electrophilic addition. Okay, why? Because actually we're going to remove the double bond. We're going to add two new bonds. So that's why it is addition. But why is it electrophilic? Because our alkene itself is actually rich electron species. So rich electron species, it means that it is a nucleophile, or specifically nucleophilic site. So what's been added to the nucleophilic site is actually our electrophile. So that's why the reaction is electrophilic addition. Okay, for the electrophilic addition, it follows the Markov-Nikov rule, where it mentioned that the electrophile will add to the carbon with greater number of hydrogen. Okay, so mostly for the reaction of mechanism, our electrophile ni is actually our hydrogen lah. Okay, so this one, so what it means that before you're going to add, remember from alkene change to alcohol, we're going to add H2O, or specifically we're going to add hydrogen and we're going to add OH. But before we're going to add the atoms itself, it is important for you to classify or to determine how many carbon attached to our carbon-carbon double bond, so that you know lah which one will be added to which atom. Okay, so let's look here. For this case around, we're going to add the hydrogen to the carbon with more hydrogen, which follows the Markov-Nikov rule lah. Okay, so that is hydrogen. So we're going to add OH to the carbon with less hydrogen. Okay, so let's look for the reaction itself. First, we have our reaction of ethene. Okay, so for the hydration of alkene, we need our H2O. We need it to add our H and OH. And H3O plus ni is actually our catalyst. Okay, so for the acid itself, you can write down H3O plus, H2SO4 pun boleh juga. But you can't write down H plus only, cannot lah. It's either H3O plus or H2SO4. But I would prefer to write down H3O plus because later when you see the mechanism, you can see it as H3O plus. So senang lah nak ingat. Okay, but then for the mechanism here, remember Markov-Nikov rule, it mentioned that we're going to add hydrogen to the one with more hydrogen. Carbon-carbon double bond with more hydrogen. So when we look for the carbon here, it has two hydrogen. The same goes for this carbon, it has two hydrogen. So do we need to follow this rule? There's no need lah, but similar saja. So we're going to add it anywhere that you want. But make sure before you're going to add H and OH, determine which one has more hydrogen, which one has less hydrogen. Okay, so first what I'm going to do is actually, for the electrophilic addition, what we're going to take is actually our alkene. Okay, what would happen is that you're going to remove the double bond. Okay, what would happen is actually, it will add two new bond. Okay, so 1, 2. Because remember, each carbon needs 4 bond, right? Okay, so for the hydration of alkene, what we're going to add H and OH. So again, because the carbon has the same number of hydrogen, so mana-mana pun boleh letak. Okay, so this is actually the reaction equation. Next step, we can do the mechanism. Okay, so there are 3 steps for this mechanism. Step 1, formation of carbocation. Step 2, formation of protonated alcohol. The last step is deprotonation. Okay, so for the first step, formation of carbocation. Okay, if you still remember what I mentioned about stability, because when we're talking about carbocation, we always have to keep in mind whether we have to do the rearrangement or not. The rearrangement, whether 1 to hydride shift or 1 to methyl shift. Okay, so the first one is the formation of carbocation. What we're going to use is actually, we're going to use our alkene. Okay, and then we will react it with our acidified water. So if you take H2O saja, salah lah. We're going to add hydrogen more towards it sebab dia acidified water kan. So what is actually the structure adalah H3O+. For the acidified water, it will be easier for you to show it in terms of expanded structure because later it will be easier to see the bond breaking, bond making. Okay, so for the movement of electron, it will be from rich electron species to poor electron species. Okay, rich electron species, kita punya double bond tu. Okay, so for the formation of carbocation ni, what's actually will be added to our alkene, we're gonna add hydrogen. Okay, so first what we're gonna take is actually the alkene itself will take the hydrogen. So tak kisahlah mana-mana hydrogen, I'm gonna take this hydrogen. So again, when this hydrogen is when the carbon take this hydrogen, this bond will break. And it will break heterotically, which it will the electron will be moving towards oxygen, since oxygen is more electronegative. Electronegative tu is actually the ability of the atom to attract electron lah. So that's why lah electron ni will be prefer go to the oxygen itself. So dia pergilah dekat oxygen. Okay, so what happened next for our product? Okay, yang ini follow balik to our Markov-Nikov rule. Remember that for our Markov-Nikov rule, it mentioned that when we add the hydrogen, first step ni kan, kita nak add the hydrogen tu, electrophile tu will add to the carbon with greater number of hydrogen. So dalam case ni, both has 2 hydrogen kan. So up to you lah which one you're gonna take. But I'm gonna choose yang this one lah. This one yang take the hydrogen itself. Okay. So again, we're only gonna add 1 hydrogen sebab memang overall we're gonna add 1 H and 1 OH. So only 1 is taken. So what happened to this carbon here? Okay, this carbon here, so istimlah kat sini because dia donate the electron kan, kat sini yang dia akan jadi positive ion, formation of carbocation. Okay, next what happened to this our H3O+? Okay, since the electron is accepted towards oxygen ataupun oxygen accept the electron, so what happened here, kat sini oxygen ni kan sepatutnya jadi negatif lah kan, tapi positif negatif cancel out, which the product will be plus H2O. Ataupun kita akan, if you want to do the expanded pun boleh juga. So we're going to take OH. Okay, so that's the first step, the formation of carbocation. Okay, just to be sure, kat sini kan, when we mention of carbocation, we have to check the stability lah. Carbocation ni kita tengok primary. The next carbon tu pun primary juga. So that's why we don't have to do any rearrangement. So that is the first step, okay? Okay, so the next step. Step 2 is the formation of protonated alcohol. So step 2, which one we're going to take? Kita akan balik we will take all the product from step 1. Okay, we're going to take here. Okay, so what happened next is actually the movement of the electron masih lagi from rich electron to poor electron species. So rich electron tu yang lone pair, remember oxygen has 2 lone pair here. So it moved to poor electron species. In this case, poor electron species kita adalah positively charged. Okay, so in this case, what would happen? The movement of the electron will be towards oxygen, pergi towards our carbon. Okay, it will move towards our carbon itself lah. So kita buat sini carbon. So what happened to the product? So when it attached to the carbon, so I'm just gonna show it here. So when it attached to the carbon, dekat sini what would happen? Maknanya carbon ni attached to our oxygen, attached to hydrogen, attached to hydrogen. Okay, but this case around, remember that the hydrogen ni has donated the electron towards the carbon kan. So dekat sini it has positively charged. Okay, how about the carbon itself? Tadi dia dah positif, but when it accept electron it will become negative. So dah cancel out. So it will be a neutral carbon. So here the formation of protonated alcohol. So maknanya dekat sini lah alcohol OH kan. Protonated alcohol tu OH2+, which is this one. So yang ini dah senang sikit sebab kita ambil je produk ni, kita gabungkan balik. It is easier that way. But okay, for the last step. Okay, the last step ni yang lain sikit. Okay, so what we're going to take, we're going to still take the product from step 2. Okay, so for the step 3 here, it is actually deprotonation, which we're going to remove hydrogen. But which hydrogen that we will remove? We will remove the hydrogen from OH2+. Okay, in this case, sebelum ni kita nampak OH2 plus ni kan, kita nak remove semua ni kan, to get our byproduct as H2O. But we don't want this case, sebab in this case kita nak OH ni. We want our alcohol. So which hydrogen that will be removed is actually our hydrogen lah. Hydrogen yang attached to our oxygen itself. Okay. Tapi which species yang akan ambil hydrogen ni? Okay. So another species that we're gonna add. Okay. Apa lagi? Which species that will take the hydrogen is actually another of our water molecule. So we add water molecule here. Okay, kenapa water molecule ni nak ambil hydrogen? Because actually the water molecule ni needs the hydrogen, wants to take the hydrogen to to become H3O plus again. Okay, so maknanya nak jadi kita punya catalyst tu lah. Okay, so again the movement must be from rich electron to poor electron. Rich electron tu yang lone pair tu lah, which is our oxygen. This case dia nak ambil apa? Remember, it wants to take hydrogen. Nak take hydrogen ni so that this molecule will become alcohol. So what happen is that from the oxygen will take hydrogen. Okay. And then when the bond break, we have to show this one nanti bond will break. So again, the electron will be moving towards more electronegative atom. In this case, oxygen is more electronegative. So we show the arrow to be this way. So the last product, what would be the product? The product would be this one. So we will remove the hydrogen. Okay, and then remember, because this oxygen has accepted two electron, so the positive negative kan cancel out lah. So we don't have any positively sign. Lagipun alcohol kan memang OH sahaja. So what will happen to this one? Okay, it's either you want to do the expand division, or it's fine if you just want to write down it as H3O plus, which is back to our catalyst. Okay, so that is the mechanism for the hydration of alkene. Okay, they're quite straightforward. Okay, first one is actually from our alkene. It will react with our acidified water. Remember, acidified water tu maknanya water H2O. Kalau acidified maknanya we're gonna add another H plus, so jadi H3O plus. Okay, this case around, so maknanya what we're gonna take, first case ni we're gonna take the hydrogen. Hydrogen tu must be added to the carbon with more hydrogen. So when you add it to the carbon with more hydrogen, okay, so when we add one hydrogen, another one akan form our carbocation ion lah. Okay, so when we forming carbocation ion, just check whether the rearrangement can occur or not. Okay, and then we have our byproduct, our water. Okay, and then from the product from step 1 ni, okay, it will combine in step 2. So we get macam our alcohol, tapi sebenarnya ada extra hydrogen lagi. So from here, how do we get OH2 ni? Macam mana dapat OH balik? We're not gonna remove all this H2O. We want to remove only one of the hydrogen je to form our alcohol. So what we're gonna take? We're gonna take another of our water molecule to take our hydrogen. Okay, once you take the hydrogen, remember the bond breaking. So bond breaking ni must be, the electron must be towards more electronegative lah. So oxygen is more electronegative kan? The electron will be moving towards oxygen. So here we will get the product of our reaction equation. Okay, so that is for the reaction of ethene. The next reaction that we will look at is actually for the case of 2-methyl-propene. Okay, so for 2-methyl-propene, again, we're going to react with water and our acidified water lah, H3O+. Our acid itself. So again, what we're going to add for this atom, we're going to add our H and OH. But before that, remember, based on Markov-Nikov rule, mentioned that electrophile must be added to the carbon with more hydrogen. So again, this is our carbon-carbon double bond. Check which one has more hydrogen. So this one attached to it, it has 2 hydrogen. So when it has 2 hydrogen, so it means that this carbon is the one with more carbon lah, more hydrogen. Okay, so it means that this one will be the carbon with less hydrogen. Because when you see here, carbon ni attached to 1 CH3, 2 CH3. So yang ini memang attached to it directly 2 hydrogen. This, there's no hydrogen attached. There is no hydrogen directly attached to this carbon. So this one will be the less hydrogen lah. Okay, so what about the product itself? So what we're going to add? So from here, we're going to remove the double bond. So when we remove the double bond, we're going to add H and OH. So H will be added to the carbon with more hydrogen. So here I'm going to remove more hydrogen. So it means that here we'll be adding my H. So what about this one? This one will be adding my OH. So that is the reaction equation. So dia macam senang sikit kan? Straightforward sahaja. Okay, so let's do the mechanism together. So step 1, what we're going to do is actually we're going to do our we're going to take our alkene. We will react it with our acidified water. Okay, so for the acidified water, remember the acidified water, it must be our H3O plus lah. Okay, so again, you don't have to write down step 1 adalah formation of carbocation ion. Just write down step 1 only pun it's acceptable. So step 1 is we will react with our alkene with our acidified water, which is our H3O plus. So do the expanded one, H3O plus. So what would happen is that, remember, from the rich electron species, remove the poor electron species. So from here is actually when we formation of carbocation ion ni, first step kan kita nak add our electrophile kan. So we're gonna take the hydrogen. From our acidified water ni kita nak take hydrogen. Okay, so from our double bond, we'll be moving towards the hydrogen. Okay, and then this bond will break where the electron will be moving towards more electronegative atom, which is oxygen. So show lah the electron moving towards oxygen itself. Okay, so what about the product? So the product here, what we're going to add is actually, don't forget, the hydrogen must be added to the one, to the carbon with more hydrogen. Dalam case ni, the left hand side lah. So again, remove the double bond. We're going to add our hydrogen. Okay, but what happened to this carbon? Okay, this carbon dah donated the electron kan, to take the hydrogen, so dia jadi positive. Okay, so what happened to our water ni? Because the acidified water, we have removed the hydrogen. The hydrogen ni dah break the bond. So what we have here is actually our water. Oh, hydrogen, hydrogen. So do step 1. Okay, so for step 2, what would happen? Before we check the step 2, we're gonna proceed with step 2. Check dulu for the carbocation ion ni. Kan ada carbocation ion kan? Check. Is it the most stable carbocation ion? So here is actually it attached to it 1, 2, 3. So tertiary. So the most stable lah. Because the one next to it, this one is primary. So there's no need for the rearrangement. Okay, so we're gonna take this reaction, the product from the second step. Okay, so what happened here is actually water will be added to this reaction. Okay, kenapa? Remember that from here kita nak form our alcohol kan, COH. So first step kita kena ambil balik lah yang water ni is being added to this reaction. So kita ambil oxygen, so it is moving towards our carbon, moving towards carbon kita. So what will be the product itself? So it means that for this reaction kita akan ambil, okay, I'm just gonna delete the classification jap. Okay, so here what we're gonna be added is we're gonna add oxygen, hydrogen, hydrogen. So yang sini dah tak ada lah. Okay, remember that oxygen ni donated the electron towards the carbon kan. So maksud dia kat sini the oxygen will become positive lah. What will happen to the carbon? Carbon ni dah accept will become negative. So positive negative, so tak ada charge. Okay, so for the movement ni, remember from the rich to poor. Rich kita ni sebab ada lontar, poor ni because we have our positively charged. Okay, so kat sini, this is our reaction, ataupun this is our product for second step. But remember, kita nak alcohol. So formation of alcohol, we need it to be OH. Ni OH tu. So again, previously we have seen kalau dehydration kan kita nak remove ni kan. We don't want to remove all of this. We're only going to remove the one hydrogen ni je. Nak form alcohol. So step 3, from this reaction, we will take the reactant for step 3. So step 3 here, so we're going to take our product. Okay, so which species yang akan ambil, which species that will take the hydrogen from here. So we're still gonna take from our yang reactor ni H2O, another H2O. So our H2O ni will take, okay, again, how does it take it? So maknanya from our oxygen ni akan ambil the hydrogen. Okay, so when it take the hydrogen, the bond here will break. But once it break, the electron will be moving to a small electronegative atom, which is oxygen. Again, tunjuk oxygen yang yang rich ni, oxygen rich ni nak ambil hydrogen kita. Okay, sebab nak jadi acidified water balik, oxygen ni take the hydrogen. Okay, show towards the hydrogen Okay, then this bond will break. The electron will be moving towards oxygen. So oxygen more electronegative. Ta-da! Okay, so what happen next is actually step 3, where we get our product to be dekat sini. The product is that the hydrogen, one of it will be removed lah. So hydrogen dah tak ada dah. Kat sini kita dah buang. Buang lah bond tu. Okay, and then OH ni kat sini mula positif. When it accept electron, become negative. So dah tak ada dah lah charge itu. Lagipun senang nak ingat, alcohol, there's no charge involved. Okay, so what happened to our H2O ni? It will become H3O+. So I'm just going to write down in terms of molecular formula. Okay, so that is actually the mechanism for the hydration of alkene. It's quite straightforward lagi. It's just that yang kalau tricky part je, just make sure that for the formation of carbocation ion ni, make sure it is the most stable one lah. Sebab bila kita ambil hydrogen, we know based upon the Markov-Nikov, is that the hydrogen will be added to the carbon with more hydrogen. Okay, yang ini yang number 2-methylpropane that we have seen the example. Okay, and then check balik dia punya stability. The carbocation is the most stable. Okay, so second step ni straightforward, masukkan saja. The third step, we have to take another of our water. Okay, so that's the end for the video for the hydration, for the reaction of hydration of alkene.